Let's solve this question here. You may pause the video first and then read the question. The key point in this question is that in a standard deck of cards, there are 52 cards and 2 jokers. So together, there are total 54 cards. In this question, you will draw 1 card on the first draw, but you will not return this card that you draw back to the deck of cards before you make the second draw. And you have to find the probability of all these situations here. Now, let's look at situation A, right? Finding the probability of drawing one of the jokers on the first draw and an ace on the second draw. Now, let's look at part A first. How many jokers are there in the deck of cards? There are 2. So there are 2 possible outcomes that you may want. Now, in the first draw, you have 54 cards to draw from. So 54 cards, right? So that is the probability of drawing one of the jokers on the first draw. Now, you have to draw an ace on the second draw. How many ace cards are there in the deck of cards? There are 4. So there are 4 possible outcomes that you may want. But remember that in this situation here, you don't return the first card that you draw, right, to the deck before you make the second draw. So you really have only 53 cards to draw from on the second draw, right? So this is the probability of drawing an ace on the second draw. Well, since they are not really affecting each other, right? So you can multiply the 2 probabilities together, and that's the probability of the entire situation A. And that would be A out of 2,862. And that's approximately equal to 0.2795%. Right? You may want to express probability in terms of percentage, right? Okay, so that's part A. Let's look at part B. A number card of any suit on the first draw and a red joker on the second draw. Now, part B. A number of any suit. So how many types of number cards are there? Notice that an ace card is not considered as number cards here. So you really have only 2, 3, 4, 5, 6, 7, 8, 9, 10. So 9 types of number card, right? And how many cards that each of this number has? Basically, how many suits does each card have? There are 4 suits, right? So in total, there are 36 number cards, right? That you can draw from. That could be the outcome that you want. So for the first draw, has to be a number of any suit, right? So since there are 36 number cards, so you have 36 possible outcomes that you want, and you have 54 cards to draw from on the first draw. So that's the probability of drawing any of the number cards on the first draw. Now, on the second draw, you have to get a red joker. Now, there's only 1 red joker card in the deck of cards. So that's only 1 possible outcome that you may want. Again, you don't return the first card that you draw to the deck of cards before you make the second draw, right? So you have only 53 cards to draw from on the second draw. Again, you multiply these probabilities together, and that will give you the probability of the entire situation B here. And that would be 36 over 2,862. And that's approximately equal to 1.26%. That's part B. Now let's look at part C together. A queen on both draws. Now part C. How many queen cards in a deck of cards? There are 4 queen cards. So on the first draw, you have 4 possible outcomes that you may want. And again, On the first draw, you have 54 cards to draw from. So the probability of getting one of the queen cards will be 4 out of 54. Now again, on the second draw, has to be a queen card too. But you already draw one of the queen card on the first draw. So how many queen cards left for you to draw on the second draw? 3, right? And you don't return the first card that you draw on the first draw to the deck, right? So you have only 53 cards to draw from on the second draw. Now again, you multiply these two probabilities together, right? The first draw and the second draw, and that will give you the probability of the entire situation C. And that would be 12 over 2,862. And that's approximately equal to 0.42%. Okay. Now, that is situation C. Now, look at Part D. Any black cards on both draws. Now, Part D. In this part here, in this situation here, we don't take into consideration the two jokers. So we have 52 cards in total. How many colors are there in a deck of cards? There are only two colors. One is red, one is black, right? So 52 divided by 2, you have 26 cards that's black and 26 cards that are red, right? Okay. Then in the first draw, you want to get any of the black cards. So you have 26 possible outcomes that you want, but you have 54 cards to draw from. So that's the probability of getting one of the black cards. Now, on the second draw, okay, it has to be a black card too. Now, since in the first draw, you already draw one of the black cards, right? And you're not returning it to the deck of cards before you make the second draw. So there are really only 25 black cards left, right? For you to draw. And again, since you don't return the card, you have 53 cards to draw from on the second draw, right? And you multiply these two probabilities together, right? Probability of first draw and the probability of second draw. That will give you the probability of the entire situation D. Okay, and that is equal to 650 divided by 2,862, and that's approximately equal to 22.71%. Okay, that is part D. Let's look at part E together. Any number card below 10 on the first draw and the same number on the second draw. Okay, so part E, when they say any number below 10, that means it does not include 10. And again, ace does not count as a number in this situation. So you really have only 2, 3, 4, 5, 6, 7, 8, 9, right? So there are A types of number, A numbers. And each number has 4 suits. So that would be 32 cards. That could be a possible outcome that you want. So on the first draw, there are 32 possible outcomes that you want. And there are 54 cards you can draw from, right? Now, on the second situation here, right? Second draw. On the second draw, it has to be the same number. Now, each number card has only 4 cards. So since you draw one of them already, on the second draw, you really have only 3 cards to draw from that may have the outcomes that you want. Now again, you don't really return the card, right? So you have 53 cards to draw from on the second draw. And again, you multiply these two probabilities together. That will give you the probability of the entire situation E. Yeah. And that would be equal to 96 over 2,862, and that's approximately equal to 3.35%. Okay, that's part E. Let's look at part F together. The probability of drawing a red joker or a red ace on either draw. Now, this is a little bit harder now. On either draw, okay? So, part F. Now, first of all, think about that. How many red jokers are there in the cards? 1. So, there's only 1 red joker you can draw from. Here. How many red ace here in the card you can draw from? There are 2, right? 2 of the red ace, because there are only 4 ace in total. 2 of them are red and 2 of them are black. So really, there are only 2 red ace there. Now you have to draw either one of this on the first draw, right? So you have 3 possible outcomes that you want on the first draw, and you have 54 cards to draw from. So that is 3 out of 54. Now, let me write it here. 3 out of 54 on the first draw, right? Now, on the second draw, if you actually get one of this card on the first draw, then you cannot get any of this card on the second draw, because in the question it says on either draw, right? Then what's the probability of getting none of this on the second draw? Well, that is the probability of getting any of the other 51 cards other than one of these 3 cards, right? So that will be 51, right? Possible outcome that you want on the second draw, which is none of these 3 possible outcome, right? Because this 2 number, 3 plus 51 is 54, right? Which is your total number of cards. Now, again, on the second draw, since you don't return the first card, you have 53 cards to draw from. And of course, right, you multiply these 2 probability, right? That will give you the probability of drawing one of the cards in part F, but none of this card on the second draw. Now, there could be a different situation where you draw one of these cards on the second draw, but not on the first draw. How will you find the probability of that? Of course, right? On the first draw, really, you have to draw one of the 51 cards that are none of these 3 cards, right? And of course, on the first draw, you have 54 cards to draw from. Now, on the second draw, you get one of this, right? So it's 3, right? One of the 3. But again, after you draw the first card, you don't return it to the deck, so you have 53 cards to draw from on the first draw. And you multiply the probabilities together. So this is the probability of drawing none of this card on the first draw, but one of this card on the second draw. Now, let's repeat this. On this side, this is the probability of drawing one of this card on the first draw, but not the second draw. And this is the probability of drawing none of this card on the first draw, but one of them on the second draw. And what do I do now? I just add them up, right? And that will give me the probability of the entire situation F. Okay, so, and that is equal to 306 over 2,862, and that's approximately equal to 10.69%. Okay, so this is the probability for part F. Hope you enjoyed this video. Don't forget to subscribe to my channel. Thank you.